Hi everyone, in this video we will discuss the problem find maximum volume of a cuboid from the given parameter and area. So basically the problem says that you will be given the perimeter and the area of a cube, like you'll be basically given a perimeter value and you'll be given an area, and what you have to do is you have to tell that because of those given perimeter and the area, what is the maximum volume cuboid that you can generate. So finally you have to print the maximum volume cuboid that you can generate up to 2 decimal places. So it's a very mathematical question. You have to apply basic mathematics. If you will see here, since I have been given what, let's say I have been given the perimeter and I have been given the area here. Let's assume that for this cuboid that we have, our length is what? Let's say our length is L. Okay. Let's say our breadth will come out to be how much? Let's say our breadth will be B. And then our height is how much? Let's say our height comes out to be H here. Okay, this is what we have. So we know the perimeter, we know the area, we have the length, we have the breadth, we have the height. Now we have to optimize the dimensions here. We have to find all the things that have been given. So what is the formula for the perimeter here? So for the perimeter, we can say that whenever we have to calculate the perimeter, the area and the volume. So for volume of a cuboid, we can say that the formula is what? Formula is basically the length into the breadth into the height. Okay. Now when it comes to the area, so what is the area of a perimeter? The area of the perimeter is basically nothing but 2 times L into B plus B into H plus what? H into L. So this is what the area is, right? So we know the formula for the volume. We also know the formula for the area as well. Now once you know the formula for volume and the area, then we can also find out the perimeter. Now what is the perimeter of a cuboid? Basically the perimeter is nothing but 4 times, like perimeter is basically 4 times length plus breadth plus height. Okay, because all the, like if length is there, if a certain length is there, it will be added 4 times in a cuboid. Similarly breadth will also be added 4 times, and then after that height will also be added 4 times for the perimeter. Now I have been given the perimeter and the area already. Now what we have to do is we have to substitute the values here, and then we have to try and maximize the volume. So we have been given the volume as what, like length into breadth into the height. Correct, this is what we have been given. So what we will do is now we will substitute the values and we will apply calculus. So what we will do is we will differentiate. Okay, we will differentiate this particular volume with respect to the length. Okay, and then after that, applying the calculus formulas, we'll try to maximize this particular equation. When we try to do that, then what will happen is our optimized, like in that case, the length will come out to be nothing but perimeter minus what? Minus under root of perimeter square minus 24 into the area. Okay, divided by 12. Right, so this is what will be our length. Then the width will be, let's say L, like basically the breadth, let's say, will be L. Okay, and then the height would be how much? The height would be, you can say, perimeter divided by 4 minus 2 times L. Okay, so when you will substitute all these values and you will try to find the L value, breadth value and H value, then you will get this. Then after that, what you have to do is you have to maximize the value of the volume, and where volume is what? Length into breadth into height. When you let length into breadth into height. So when you will substitute these, then you will get a formula in terms of L, and then you can apply that in order to get the maximum volume. So this is what we have to do here. It's very basic. Since you have been given the perimeter already, you have been given the area already. So first of all, let's say the length of your cuboid is how much? Let's say it is L, breadth is B, height is H. Then the volume is basically length into breadth into height. Area is 2 times length plus breadth into height plus height into length. Okay, then perimeter is 4 times length plus breadth plus height. Now after that you can say that you have to maximize the value of volume. Now you can find everything in terms of L. So L, like if you will substitute the values here, so you'll get L as this, then breadth will be this, and height will be this. Now when you'll substitute in V, and then you will differentiate the volume with respect to the length, and then after that you will try to optimize, then you will get the formula. So let me write this final part here. What you will do here is, like when you will basically optimize this part, so what is the value that you will get? So the volume that you will get is the maximized amount of volume that you will get is what? It will be basically you can say perimeter minus under root of perimeter square minus 24 times the area that has been given to you. Okay, and then this whole divided by 12, and this will be to the power 2 here. Okay, then what you will do is you will multiply this with what? You will multiply this with perimeter divided by 4 minus 2 times perimeter minus under root of perimeter square minus 24 into area whole square divided by 12 here. Okay, and this was also divided by 12. So when you'll solve this, then you'll get this particular formula. Now you just need to apply it. So let's write this here. So this is a constant operation because you're not taking much time here. So what you'll do is you'll basically return what? You will return the power of what? The perimeter minus the square root of power of p comma 2, that is p to the power 2 minus what? When I come out, this will be minus 24 into the area. Okay, then we can close this, and let's just quickly see this. So yeah, then you have got minus 24, so you close this as well. Now yeah, I can open one bracket here also in order to keep this expression as a whole. Okay, so you'll close this also, and then you will divide by 2. Okay, and then we need to make this like this. Okay, so we have closed this right here. Okay, so after this we can open a bracket like this, and to the power 2 here, so comma 2 here. Then after that what we'll do is we'll multiply it with what? We'll multiply it with p by 4, as I already showed you in this part, right? When you'll solve it, so you'll multiply it with p by 4, that is when you'll substitute, so you'll get p by 4 here, so you'll multiply it with this value, and then after that you'll subtract it with what? You'll subtract it with 2 times the perimeter minus the square root of power of p comma 2, okay, minus what? Minus the value, that is 24 into s. Okay, then you'll close 1 2 3 4, all these brackets would get closed, and then you will divide this by 12 here. And now once this is done, so I guess we can close the other brackets also. So yes, we have got this bracket. Let's open this like this. So basically p by 4 minus this part, so I've opened one bracket here. Okay, then p by 4, then I'm having minus sign. Okay, that's fine. Then p, then I'm opening this bracket, then I'm having p minus power of p comma 2 minus 24s. Okay, then we'll close these brackets, then divide by 12, then we'll close this. Okay, then closing one more here, closing one more here, and one more here. Okay, so let's check if I'm closing the brackets correctly or not. So let's try and compile this now. So yeah guys, you can see here that I'm getting this area, and now let's submit this and it will get accepted. So basically you'll get this by doing some differentiation. So this is a problem which is purely mathematical in nature. It does not require any DSA. It requires differentiation skills. So I hope you have understood it clearly. Thank you for watching this video.